Our today's topic is dimensions. Before defining dimensions, let's discuss system of units. We know that there are different system of units such as FPS, CGS and MKS. So according to that system of units, one physical quantity may have different units. For example, distance or length can be measured in meters or feet. Velocity can be measured in meter per second or feet per second, and you can have many examples of physical quantities with one or more units. If we are measuring length in meters and someone is measuring length in feet, so we both are correct, but this may create confusion to us. So, to resolve this issue, dimensions play their part. Dimension is to solve the confusion of units in the universe. Let's try to understand what dimension exactly is. We have taken formula of velocity as an example, having units meter per second or feet per second, whatever you take, it's your own choice. When we talk in terms of dimensions, we write meter as capital L, or whatever the quantity is that is measured in length or distance is represented by capital L. It doesn't matter that whether you choose meter or feet for representing distance or length, both are represented by capital L, and for time, second, we write capital T. From this we can write the formula of velocity meter per second is equals to L divided by T. Here whatever you take, meter per second or feet per second, that both will be equals to L divided by T. Now we have dimensional formula of velocity L to the power 1 T to the power minus 1 into brackets. Here L and T are not dimensions of velocity. These are only way of representations to get actual dimensions. Now we can define dimensions. Dimensions are the powers to which these quantities are raised to. Here this quantity of length is raised to the power 1 and this quantity of time is raised to the power minus 1. So we have dimensions of velocity 1 and minus 1. Now we can define dimensions as the dimension of a physical quantity is defined as the powers to which the fundamental quantities are raised in order to represent the quantity. The seven fundamental quantities are enclosed in square brackets to represent its dimensions. Symbols for different dimensions. We find that the dimensions of all physical quantities can be expressed as combinations of a few fundamental dimensions. So we have different particular symbols for writing dimensions. For length, we use capital L. For mass, we use capital M. For time, we use capital T. For electric charge, we use capital Q. For electric current, we use capital A. And these all are written with square brackets. We have some physical quantities such as area, volume, speed, and acceleration, having units meter square, meter cube, meter per second, and meter per second square respectively in SI units. But they can have other units as well. And we know that for writing dimensions, it doesn't matter that which system of unit is given, because to solve this confusion of units, we use dimensions. So for area, we can write capital L square. For volume, we can write capital L cube. For speed, we can write capital L divided by T. For acceleration, we can write capital L divided by capital T square. This is representation for dimension. Now we will calculate the dimensions of these quantities. We started our discussion with velocity, so let's calculate the dimension of velocity step by step. First of all, for writing dimensions, we write formula of physical quantity. Here physical quantity is velocity and its formula is velocity is equals to displacement divided by time, that is s divided by t. We know that for quantity s, that is displacement or distance or any quantity that measures length, we write capital L with square brackets, and for time we write capital T with square brackets. Here you can see that I have written L to the power 1, M to the power 0 and T to the power 0 in numerator, and in denominator L to the power 0, M to the power 0 and T to the power 1. It's a standard way of writing. We can also write L to the power 1 divided by T to the power 1, but it's good to write M and T with L, and we get M to the power 0, L to the power 1, T to the power minus 1. Standard way of writing is, first of all we write M, then L, then T. And now from this we know that dimensions are the powers to which these fundamental quantities are raised to. So fundamental quantities are raised to the power 0, 1 and minus 1. So we get the dimension of velocity. Dimension of force. We know that formula of force is equals to mass into acceleration, where acceleration is velocity divided by time and velocity is length divided by time, and we get F is equals to mass into length divided by time square, and force is equals to mass into length into time to the power minus 2. For mass we write capital M, for length we write capital L, for time we write capital T, and the power of mass is 1, power of length is 1, power of time is minus 2. So we write M to the power 1, L to the power 1 and T to the power minus 2. This is the dimensional formula M, L, T minus 2 with square brackets. So dimensions of force is 1 in mass, 1 in length, minus 2 in time, and in a standard way we write it as in square brackets 1, 1 minus 2. Dimension of eta, coefficient of viscosity. From formula we know that F is equals to 6 pi eta VR. Now you will calculate dimensional formula of force and dimensional formula of velocity as we have already calculated in previous slides. So I'm just directly taking that formulas and putting in this equation, and we get ml t to the power minus 2 in square brackets is equals to eta into L t to the power minus 1 in square brackets, and here capital L is for radius r and it is written in square brackets. By solving we get eta is equals to m L to the power minus 1 t to the power minus 1, and the dimension of eta is 1, minus 1 and minus 1. Now we are going to calculate the dimensions of h, Planck's constant, as we know that from formula E is equals to h mu. H is Planck's constant. For finding its dimensions we need the dimensional formula of E and mu, frequency. For energy we know that E is equals to mc square. You will calculate the dimension of c by putting the formula speed upon time, and then you will get m to the power 1, L to the power 2 and T to the power minus 2 in square brackets. I did it directly, but you will do step by step. And we know that frequency is 1 divided by time t, and for t we write dimensional formula as capital T in square brackets. By putting dimensional formula of E and mu, we get m L to the power 2 T to the power minus 2 is equals to h into 1 divided by capital T. And finally we get h is equals to m l to the power 2 t to the power minus 1. Here we know that the power of these base quantities, fundamental quantities, are 1, 2 and minus 1, and these are basically the dimensions of Planck's constant. H is equals to 1, 2 and minus 1. Dimensions of gravitational constant G. From formula we know that F is equals to G m1 m2 divided by r square. Now you will calculate the dimensional formula of force, and then by putting in this formula we will get ml t to the power minus 2 in square brackets, that is dimensional formula of force, is equals to capital G gravitational constant m into capital M square. Here capital M is representing quantity in mass, because there are two quantities m into m, that's why we write square of capital M. And as distance r is represented by capital L, so we write capital L square. By solving this we finally get m to the power minus 1 L to the power cube and t to the power minus 2. So the dimensions of gravitational constant are minus 1, 3 and minus 2 in square brackets. By the help of dimensions, we can verify the relations or expressions. Find the correct relation. F is equals to mv square divided by r. Now we have to calculate that is it correct or incorrect by the help of dimensions. Checking the dimensionally correctness of relation, as we know that dimensional formula of force is m to the power 1, L to the power 1 and t to the power minus 2. You will calculate it here, but I have written it directly. So left hand side is equals to m L t to the power minus 2, that is m to the power 1, L to the power 1 and t to the power minus 2. On right hand side we have mv square divided by r. For m we write capital M, for v we write L t minus 1, because there is v square, so taking the whole square, divided by L, because for distance we write capital L. And by solving it we get right hand side is equals to m to the power 1, L to the power 1 and t to the power minus 2. By comparing left hand side and right hand side we can see that both are equal, that is m to the power 1, L to the power 1 and t to the power minus 2. Hence it is proved that left hand side is equal to right hand side. That's why this relation is correct. F is equals to mv square divided by r. Here different quantities with units, symbol and dimensional formula are shown. Try to calculate these dimensional formulas by yourself. Advantages of dimensional analysis. Necessary either to drive a math expression or equation or to check its correctness. Quantities can be added or subtracted only if they have the same dimensions. The terms of both sides of an equation must have the same dimensions.